Alright, today we're going to learn how to multiply a polynomial by a monomial. This is section 8.2 in your book. And first we probably should make sure you know what we mean by polynomial and monomial. A monomial is just a single algebra term like 8x. A binomial is two algebra terms combined by either addition or subtraction, like negative 3x squared plus 5x. That would be a binomial. And when we talk about a polynomial, that is more than one monomial added or subtracted together. So technically this binomial is also a polynomial. A polynomial could also be something like 5x cubed minus 7x squared plus 9. That is a polynomial. Three algebra terms combined by addition or subtraction. And in today's assignment, you're going to be multiplying a monomial by a polynomial. So here's the first example. Let's say that we have negative 3x squared times 7x squared minus x plus 4. Well, we have to use distributive property a lot today, so I'm going to distribute this multiplication to all three terms in here. So now I have to think, what is negative 3x squared times positive 7x squared? Well, that is negative 21x to the fourth. Remember, we add those exponents when we're multiplying with like bases. Then I have to do this negative 3x squared times the negative x. So that's going to be positive 3x cubed. And I have to distribute one more time to this 4. So negative 3 times positive 4 is negative 12x squared. And that would be our answer to that problem. Alright, let's do another one. Call this number 2. This one's going to be a little bit longer. Let's say that we had p times negative 4p squared plus 6p minus 5 times 2p squared plus 20. Now this is the same type of problem as what we just did, but I have two sets of parentheses, which means I need to do distributive property separately on each one. So let's get started. When I distribute here, I'm going to have negative 8p to the third. Remember, this exponent here is a 1. 1 plus 2 is 3. Then I distribute here, and I have plus 12p squared. Notice that the terms have to be connected by addition or subtraction. Now I need to distribute with the second set of parentheses. So that will be negative 10p to the second. And then I distribute to the 20. And I have negative 100. Now, I am not done with this problem because we always want to try to combine like terms if we can. And these two are like terms because they're both a p squared term. Alright, so I just look at the coefficients. Positive 12 and negative 10. That makes positive 2 p squared The other things I just bring down. So I'm going to have a negative 8p to the third, plus 2p squared minus 100. So you're going to have several problems tonight of each type. Some where you're just distributing a single monomial to a polynomial and you get an answer, and then several where you've got to distribute and then combine like terms. Now there's one other thing that you're going to be asked to do tonight, and that's solve. And when we're solving, you're going to have to use the skill that we just learned and then solve the equation. So let's look at this first problem. 2x times x plus 4 plus 7 equals x plus 8 plus 2x times x plus 1 plus 12. So notice this is an equation. We've got an equal sign here. So we're solving now. Let's do distributive property just like we did on the first two problems. Distribute, distribute, and I have 2x squared plus 8x. I don't distribute to the 7. It's outside of parentheses, so it just comes down. Here, this x plus 8, I can drop these parentheses because there's nothing being distributed on the outside. So I just have x plus 8. Plus, here I do need to distribute 2x squared plus 2x plus 12. Now, let's combine some like terms here. On this right side, I've got an x term here and here, so that turns into 3x. And I've got an 8 and a 12, which makes plus 20. And then I just have this plus 2x squared. On the left-hand side, I've got 2x squared plus 8x plus 7. Well, you might be wondering what we're going to do with these x squared terms. Well, later on, we're actually going to learn how to solve what's called a quadratic function that has these. But for right now, I want you to see that if I subtract 2x squared from both sides, the x squared terms simply go away. And that's what's going to happen. If you see an x squared term or an x cubed term tonight, when you subtract them or add them to both sides, they're going to disappear. So you won't have to worry about them. So now I just have a regular algebra equation that everybody should be able to solve. I would subtract 3x from both sides, so I have 5x plus 7 equals 20. Subtract 7 from both sides, 5x equals 13. Divide both sides by 5, and I have my answer. X equals 13/5. Just a little reminder that sometimes when you're solving equations, it's possible that you could get an answer of infinitely many. I don't think this happens a whole lot tonight, but I just wanted to bring it up to you and remind you. Or you could have no solution. All right. Those happen when all of the x's go away, and then I'm left with either a true statement or a false statement. Okay, we've seen that a lot this year. So I'm going to stop there for now and let you get started on today's assignment.